Now we've talked about how to sample with means, and we went over an example using a probability and an example using the empirical rule. We're going to do the same thing for sampling with proportions. And so the good news is it's essentially the same process. We're just going to have a little bit of vocabulary change. And so before we talked about the mean was the population mean, and then we either called it y bar or the mean of x bar, or any of those really represented the mean of the sample. So now we're going to look at the population being p, the population proportion. Remember that proportion just tells us that it's going to be a percentage, part of a whole. The sample proportion is going to be p hat, just like we did when we did linear regression and we were dealing with a predicted value. That's kind of what we're doing here. The standard deviation is going to be PQ over N. So the actual p-value, if we should have it, is PQ over N. And then, of course, Q is just going to be 1 minus P. So P, of course, probability of success. Q is the 1 minus that. So, and again, we're just going to end up using the normal model. So let's take a look at what that's going to look like. Of course, we have to check our conditions first, and I want you to notice that this condition is the same, randomization. This condition is the same, 10%. This condition is the same, as independence. The only one that's different is this used to be large enough, and now we're saying let's have at least 10 successes and at least 10 failures. Now to compute the number of successes and failures, if it isn't given in the question, we would just take n times p, n being the total number, times the probability of success, and then n times q, probability of failure, and both of those have to be at least 10. So really the same idea so far, just one different condition. We're still then, of course, going to check the conditions, draw our picture, figure out which way we're shading. We're doing the normal model, so it's the z-score. The only thing different here, of course, this used to say mean and then y bar, but, y bar and then mean. Now it's observed, which is our p hat, minus expected, which is p, over the standard deviation, which is now PQ over N, and then the square root of all of that. So just make sure you're computing this in your calculator correctly. So let's take a look at what this might look like. So Groovy M&Ms, I've noticed now they have chili M&Ms and honey nut M&Ms, which is interesting. But Groovy M&Ms are supposed to make up 30% of the candy sold. In a large bag of 250 M&Ms, what's the probability that we get at least 25% Groovy candies? So again, this is expected. So this is our P. At least 25, that's what we're testing. That's our P hat. We're going to check those conditions. So random, we can assume M&Ms are put into bags randomly. 10%, obviously 250 is less than 10% of all M&Ms. Independence, because of the high sample size, colors of M&Ms are independent. And then success fail, N times P, we would multiply those to get 75. And again, P was the 0.3, 30%. And notice here, N times Q, if P was 0.3, then 1 minus 0.3 was 0.7, and that's where I got Q. And both of those are greater than 10. So it meets all of the conditions, so we're going to use the normal model, where the mean is 0.3 and the standard deviation is P times Q over N and then the square root. And notice that I've rounded to 3 places. I would go to 3 or 4 places each time you do that. Now I'm going to draw a picture, and I know that in the center of the picture goes my 0.3 because that's what's expected, and that always goes in the middle. In this case, we're looking to get at least 25% Groovy candy. So notice from here, I shaded to the right because I wanted to know 25% or more Groovy candies. Now, of course, I'm going to perform the calculations, and that is observed or predicted minus expected over the standard deviation. This, of course, is what I just computed on the other screen, and I get my z-score. Notice here I'm finding the probability that P is greater than 0.25, which means that Z is greater than negative 1.73, and then I used the same method here. So again, to find this value, I'm either using my calculator or I'm using the StatCrunch capability in the normal calculator. I'm not going to show you that again. but you can feel free to pop over to StatCrunch and double check my answer. And then state the conclusion in context. According to the normal model, the probability that a typical bag of 250 M&Ms contains at least 25% Groovy M&Ms is approximately 95.8%. So we feel fairly certain that we'll get at least 25% Groovy candies if we're expected to get 30. Now, same idea happens with the empirical rule. We don't know it, but 52% of voters plan to vote yes in an upcoming school budget. We're going to poll a random sample of 300 voters. That's our N. What might the percentage of yes voters appear to be in our poll? Again, notice it's not saying what's the probability or what are the chances. It's saying what might we expect to see. So right away we should be thinking empirical rule. So we check the conditions. Voters are selected randomly. 300 is less than 10% of all voters. Independents, voters' opinions are independent of one another. And then success fail, this is my P. So of course 300 times 0.52, my Q would be 1 minus that, which is 0.48. Both of those values are over 10, so I can continue. Again, because the conditions are met, I can use a normal model. And the calculations here would be the mean of 0.52, or the proportion. And the standard deviation is PQ over N and then the square root. And then that's my new normal model. So again, using the empirical rule, that just means we're now going to start at the 0.52 and then subtract the standard deviation to the left and add it to the right. And then our conclusion is essentially saying what we see in our picture. So according to the normal model, we expect 68% of the samples of 300 voters to have proportions of yes between 0.491 and 0.549, etc., etc., etc. Notice the way that I've phrased this. I'm not saying 68% of the time that I'm going to get this percent of voters. I'm saying 68% of the samples will have a proportion in this range, and 95% of the samples will have a proportion in this range, and 99.7% in this range. So make sure you're very careful about the way that you're phrasing it. And notice I did specify that I was talking about samples of 300.